Hello and welcome to this training video on the standard system settings and general preferences on the AVX-10K Flightline test set from Viavi Solutions. In this video, we will be reviewing the settings that are common to most test applications performed by the AVX-10K. We will go into unique preferences for each test in dedicated videos later in this series. Let's begin by looking at the test applications in the transponder ribbon, which include Transponder Auto, ADSB Auto, ADSB Monitor, GICB, and UAT Monitor. The general setup panels for each test have many common settings. They are connection type, coupler or antenna loss, cable length, and cable loss. These values and settings need to be entered whether you are testing with the flat panel antenna, directly or via the couplers. To keep things simple, we will use the Transponder Auto test setup screens for the remaining examples in this video. There are three connection methods for testing the aircraft: over-the-air antenna, direct connect, and direct connect with coupler. In the first method, antenna, a cable runs from the flat panel antenna to the ANT connector on the AVX-10K. Familiarize yourself with the location of the loss value label on the antenna and connection cable for use later in the setup process. The second test method is the direct connect type, RFIO, where the AVX-10K is directly connected to the RF port on the transponder. The cable from the unit under test is attached to the RFIO connector port on the AVX-10K. Loss value for the cable used can be found on the cable label and will be used later in the setup. If you don't have a cable loss value, the AVX-10K will automatically enter a loss based on the length of the cable. Ideally, the measured loss value noted on the cable is the most accurate. The last test method is direct with coupler. The couplers are attached to the RFIO connector port on the AVX-10K. The loss values for the coupler and connecting cable can be found on the coupler and cable and will be used later in the setup. The test method is set via the RF port option. Press RF port on the display to see a pop-up menu with the three test methods and choose the option suited to your needs. Let's choose antenna, ANT, and review the options available. The ANT identifies which RF port to plug the antenna into. Note, care should be taken to avoid interference with ATC or nearby aircraft when performing radiated, over-the-air, testing of ADSB transponders in the airborne condition at any test altitude above field level. The two settings related to the antenna are antenna settings and the cable settings. This illustration shows how to find the antenna range and height values. The height value is the difference in height between the flat panel antenna and the aircraft antenna. If the test set is set physically closer or farther away than the range entered, the resulting test readings will be inaccurate. The top antenna range and height also need to be entered when testing diversity transponders. The diversity test selection allows for separate testing of the top and bottom transponder channels. Now that we have the range and height values, let's enter them into the AVX-10K. Press the antenna settings button to see the range and height option selections. It is important to accurately enter the range and height values to generate the best test results. To enter the range settings, press the bottom antenna range option and enter the bottom antenna range value. To enter the height settings, press the bottom antenna height option and enter the bottom antenna height value in feet. Repeat the process for the top antenna height and range if diversity test is set to on. Next, you will need to enter the gain values that can be found on the flat panel antenna label. Using the correct gain values for the antenna being used is essential to receive accurate parametric and MTL measurements. Now go to the antenna gain settings window and enter the gain values as shown on the antenna label. The flat panel antenna cable values are the final settings required for a proper setup. Using the back arrow, on either the touchscreen display or the cursor key, go back up one level and select the cable settings. The resulting screen will show options for the cable length and the cable loss. Press the bottom antenna cable length and enter the cable length. Next, enter the cable loss values. The cable loss value can be found on the cable label. Select the cable loss and enter the values found on the cable. There you have it. As we said before, the settings for radiated testing using the antenna test setup are the same regardless of the test you perform. The next test method is direct connect. In this scenario, the cable is directly connected to the unit under test and the RFIO port of the AVX-10K. You will need the connector cable loss value from the sticker on the cable and the connector cable length. We were previously in antenna mode. To access the RF port options, press the RF port button. Now, choose Direct Connect RFIO from the list. The RFIO in parenthesis identifies which port to connect to the AVX-10K. Your test set display should now look like the following. RF port reads Direct Connect RFIO. Common settings for direct connecting are straightforward. We need to enter the cable length and the cable loss, both of which are found on the cable label. Select bottom direct cable length and enter the value found on the label. And then, select bottom direct cable loss and enter the value. And just like with the flat panel antenna, top cable length and loss options become available when diversity is set to on. The final test method is direct connect with coupler. The couplers are attached to the RFIO connector port on the AVX-10K. The loss values for the coupler and connecting cable can be found on the coupler and cable and along with the connector cable length, will be used later in the setup. We were previously in the direct connect mode. To access the RF port selection options, press the RF port button. Now, choose Direct Connect with Coupler RFIO from the list. The RFIO in parenthesis identifies which port to connect to on the AVX-10K. The antenna settings are now grayed out and the cable settings and coupler settings are now available. When working with couplers, loss and cable length values need to be entered. Look for the loss value labels on the coupler and the cable and enter these values in the appropriate windows. Press the Cable Settings button to access the cable settings. Now set the coupler cable length values. And then the coupler cable loss values. Now set the loss values for the coupler. Press the coupler settings option. Now press the bottom coupler loss option and enter the value from the coupler. When diversity is set to on, the top coupler loss settings become available. And those are the standard settings for direct connect with coupler. Using the mode S address as an identifier, the AVX-10K can automatically determine the mode S address of the transponder under test. In the auto condition, the AVX-10K sends out an all call. The transponder will respond with its mode S address. The AVX-10K will also use the UUT address to save test results by including this information in the name of the test result file. This helps technicians look up and manage reports by aircraft. To automatically detect the mode S address, select the UUT address button. In the pop-up, click the UUT address mode button and then select Auto. When testing with the UUT address in the manual condition, for example, in a high-traffic environment or with weight on wheels, the operator must input the mode S address for the UUT to respond. To manually enter the mode S address, select the UUT address option. Select Manual in the resulting pop-up. To change the mode S address, click the UUT address button and enter the address using the on-screen keyboard. Up to this point, you have heard us talking about how the diversity setting allows for testing of both upper and lower antennas via all three test methods. The default of diversity test is off, or testing a single-channel transponder. When performing diversity testing, it is recommended to cover the antenna not under test with a coupler. The diversity test setting has only two options: off or on. Diversity off is used when testing a single-channel transponder antenna usually installed on the bottom of an aircraft. Diversity on is used when testing a dual-channel transponder with antennas installed on the top and bottom of the aircraft being tested. To set the diversity test setting, press Diversity Test. Select Off when testing single-channel transponders. Select On when testing dual-channel transponders. The final standard setting is the Verify Unit Setup configuration. Verify Unit Setup configuration turns on or off the setup confirmation message that appears when selecting the Run Test button. In this window, you can confirm all of the setup parameters before initiating the test. This prevents stopping and restarting the test by providing a final chance to verify your setup parameters are correct. It also prevents test failures due to improper setup before initiating a test. To show the setup confirmation before testing, set to Yes. To hide the setup confirmation before testing, set to No.